All right, in this podcast, we're going to talk about the concept of molarity. Okay, so first off, we need to know what concentration is. Concentration is the measure of how much solute is dissolved in a specific amount of solvent. So up here at the very top, you see that we have light colored solution and then a very, very dark solution. So this is a very concentrated, so a lot of solute, and this is dilute, so very little solute. Same picture down here. So red are our solvents, and then the blue represent the solutes. So you can see in the concentrated, there's way more solute and way less in the dilute. All right, so a molarity is one of the ways that we can quantify concentration. Molarity is abbreviated capital M, and it's equivalent to the moles of solute over the liters of solution. Okay, so if you see over here, we have same molarity, even though we have different volumes because the concentration is the same. Same with our water. Now here in our helium gas, you see that we have different numbers of gas molecules. So that's going to be different moles of solute. So that's different molarities. Same here with our NaCl as our solute. Those are going to be different molarities. Okay, so now let's practice how we would actually solve one of these problems. Okay, so it tells us we have 95.5 grams of calcium chloride and 1.25 liters. We need to calculate the molarity. So remember that molarity equals moles of the solute over liters of the solution. So I definitely have my liters right here. I need my molarity, but all I have are grams. So I need to get those grams to moles. So 95.5 grams over 1. And then to get to moles, I'm going to want to put my molar mass of calcium chloride down here, which is 110.98. And that is equivalent to 1 mole. And then when I work out my math, I get 0.86 moles. Okay, now I'm ready to go plug it into my equation. So molarity equals my 0.86 moles over my 1.25 liters of solution, which gives me a concentration of 0.69 molar. Okay, now this problem is asked a little bit differently. This problem asks us how much potassium bromide in grams we need to add to water to prepare a half-liter solution that has a molarity of 0.125. So remember the molarity equation. Okay, so I definitely have my molarity, and I definitely have my liters. I'm trying to find grams, so I can solve for my moles and then convert to liters. So plugging in my variables, X is going to be my moles. Okay, and then you cross multiply to get X by itself. And you get forgot a 0. Okay, you get 0.0625 moles. Okay, now I need to get that to grams of potassium bromide. So I'm going to put it over 1. And then that means 1 mole goes down here. And the molar mass of potassium bromide goes on top, which is 119 grams. And I get 7.44 grams of potassium bromide needed. Okay, so it is important that you know how you actually make a solution that has a specific volume and a specific concentration. Molarity is frequently used, so that's what we're going to focus on. All right, so first things first, when you make a solution that has a specific molarity, you're going to have to do some calculations because we don't have any balances that measure moles or molarity. So we're going to have to do a little bit of calculations. So suppose we needed a 0.5 liter solution of 0.125 molar KBr. hopefully that problem sounds familiar to you because we actually just did it. So we found that we needed 7.44 grams of our potassium bromide. This is going to be a solid in a stock bottle. And we want to make 0.5 liters of this solution. So now we've done our math. We know how much potassium bromide we need. Now we need to gather our materials. Okay, so we're going to need a beaker or a weigh boat. You could use a weigh boat to measure your solid. You're going to need a balance or scale, something that's going to help you with your mass. You need a stir bar, and you can use magnetic stir bars. They kind of spin around on the bottom. Very useful little thing. Or if you have to go old-fashioned, you can always use a stir rod. And the most important equipment is definitely going to be this volumetric flask. So they're kind of funny shaped. They're like roundish towards the bottom, and they have really, really skinny necks. And there will be a line on it. Okay, that is a very, very calibrated line. It means that they have been specially made, specially designed, so that that is going to be that exact amount volume, like very, very precise. Okay, and then we're going to need a pipette, and the pipette will be used to bring our volume of our solution up to that line, so it's exact. All right, now volumetric flasks come in varying sizes. You definitely want to use the size that corresponds to how much solution you want. So like in our previous example, we wanted a 0.5 liter solution. So I'm going to need a 0.5 liter volumetric flask, also known as a 500 milliliter. Okay, so now that we've done our math and we have gathered all our materials, now it's time for our steps. So first thing you want to do is weigh out the exact amount of solute that you need for your solution. So this would be our calculations. So for our potassium bromide example, it would be 7.44 grams. Then you're going to take your solute and you're going to put it into your volumetric flask. Remember, the volumetric flask needs to be the exact volume of liquid that you are trying to make, the exact volume of solution. Then you're going to add distilled water to the volumetric flask until you get close to that little mark I told you about on the neck, the volume mark. Then we're going to take our clean pipette and we're going to finish adding distilled water in small amounts until the water line is at the bottom of the meniscus. And just in case you are unfamiliar with what the meniscus is, okay, so the meniscus is kind of like, it makes the water level adhesion and cohesion properties, makes it kind of make a little dip. So you just want to make sure that it is, the bottom of it is even with your volume line. And then you're going to stir. So hopefully you have a fancy stir bar and you can just throw it on a stir plate and let it do its thing. If not, you can always get to swirling or perhaps you might have to get it to dissolve and then pour it in your volumetric to bring it up to the appropriate volume. Okay, and here is a little schematic, a little, kind of step-by-step for if you were making a 250 milliliter solution of 1.4 molar ammonium dichromate. So if you do your calculations for 1.4 and 250, you will find that you need a specific amount of moles, and when that is multiplied by the molar mass of ammonium dichromate, it ends up being 90 grams. So you weigh your 90 grams of solid, you put it into your volumetric flask, take your liquid DI water, you pour it in there, and then you want to make sure that your water level gets exactly even with that mark.